Wow, I actually did it. I'm in math. This is awesome. It's okay, nothing can hurt me here. Wait a second. Hi everybody, welcome to another edition of Lost in Math. I'm Mr. Wheeler, and today we're finding the slope of a line on the coordinate plane. So slope. You've probably heard of slope before, but in math, slope is a ratio that describes the steepness of a line. A slope compares the vertical change in a line, which we're going to refer to as the rise, to the horizontal change in a line, which we're going to refer to as the run. So slope equals rise over run, the vertical change over the horizontal change. So let's try and find the slope on the first example on our notes. In order to find slope of a line, we need at least two ordered pairs that are on the line. On our first example, we have one at -3, +3, and another one at 3, -1. So to find the slope of this line, I want to find the rise and the run that would get me from that point to that point. I like to start on my leftmost point. You don't have to though. I'll show you later that it doesn't matter which way you do it. You'll get the same answer either way. But we're going to start here and try and get there. So I like to do my rise first. So to get from that point to that point, how far do I have to go up or down? So I have to go down 1, 2, 3, 4 units. Since I'm going down 4 units, when you go down in slope, that's a negative move. So my rise would be -4 because I had to go down 4. Next, we want to find our run. To get from where we are now to where we're going, we have to go forward 1, 2, 3, 4, 5, 6 units. So my run, I went forward on run. When we go forward, it's positive. When we go backwards, it's negative. So I went forward 6 units. So my run is +6. We express our slope as a ratio, rise over run. In this one, my rise was -4 and my run was +6. So my slope would be -4 over 6. Slope should always be reduced if it's a fraction. So on example 1, my slope was -2/3. Like I said, it doesn't matter which ordered pair you start at. If I had started in my other ordered pair to get from there to there, I would have had to go up 4 if I did my rise first. So I went up 4. So in this case, my rise is a +4. My run, now I have to go backwards 6. So my run was a -6. So if I went from this point to this point, I would have gotten a +4 over a -6. Positive divided by a negative is still a negative, so it still reduces to the same slope of -2/3. So it doesn't matter where you start, you'll end up with the same answer as long as you are careful in your work. So that's finding slope. You need two ordered pairs, and then you find the vertical and horizontal change to get from one ordered pair to the other. Write your answer as a reduced fraction, and you're done. So why don't you try the next two examples on our notes, and we'll see how you did. On example 2, to get from this point to this point, first my rise, I went up 1, 2, 3, 4, 5, 6 spaces. So I went up 6, and I went forward 3. So that's up 6, forward 3. So my slope is at 6 over 3. Reduced, my slope is 2. If you want to write your slope as 2 over 1, that's perfectly fine. After we reduce, to check, to be sure we did it right, since my slope is 2 or 2 over 1, That means if I started at my original point and went up 2 and forward 1, since that's the same slope, I should still be on my line. And if I do that, it works, and it works, and it works. So that's a way to check if you reduce your fraction to get a different answer. Example 3, it gives you multiple ordered pairs. It doesn't matter, you just pick 2. So if I picked those 2 there, my slope would be down 1, negative 1, forward 2, positive 2, so negative 1/2. If I had picked those 2 dots, I would have gone down 2 and forward 4, so negative 2 over 4, reduce the fraction, still negative 1/2. So it doesn't matter how many ordered pairs there are, just pick 2 of them and you can find your slope that way. The 2 examples on the bottom of our notes are special cases. On this one right here, to find the slope, same thing, we go from one ordered pair to the other. On this problem, my rise is 0. I just go forward 4. So my slope would be 0 over 4. 0 divided by any number is 0. So my slope would be 0. So when we have a flat horizontal line, our slope is 0. On the next one, to get from that point to that point, my rise is up 4. My run is 0, so my slope is 4 over 0. We can't divide numbers by 0. It's undefined. How many zeros can fit in a 4? Infinitely many, so that's why it's undefined. So the slope of a vertical line has an undefined slope. In general, lines that rise from left to right, those are positive slopes. Lines that fall from left to right, those are negative slopes. And flat lines, horizontal lines, are 0 slopes. Vertical lines are undefined slope. The next example wants us to draw the line. In order to graph a line, I need a point on the line and the slope of a line. And it gives us both of those. It tells us that our line goes through the origin, so I know the point 0, 0 is going to be one of the points on my graph. It also tells us the slope is positive 2/3. So that means positive 2 is my rise, positive 3 is my run. So it would go up 2 and forward 3, and I would have another ordered pair there at 3, 2. And then if I went up 2 and forward 3, I would be off of my graph. On our notes and homework, we should always plot all possible points that are on my graph. So I have 2 ordered pairs, but I can find others. If I go up 2 and forward 3, I'll be off of my graph. But we can also find points by doing the opposite maneuver. So instead of going up 2 and forward 3, if I start back at the origin and go down 2 and backwards 3, the ordered pair negative 3, 2 right there, that would also be on my line. Negative 2 over negative 3 is the same slope as positive 2 over positive 3. A negative divided by a negative is a positive. So they're the same slope, they just look different. And now I have 3 points for my graph, connect them with a line, arrows on the end, and I'm done. So why don't you try and plot all the points on the 2 example problems at the bottom of the page. The first problem says that it goes through the point negative 3, 3 and has a slope of negative 1/2. So we start at the ordered pair negative 3, 3. And the slope is negative 1/2. The negative sign is in front of the fraction, so it doesn't matter where we put it. It's either negative 1 over 2 or 1 over negative 2. Both of those are negative 0.5. They're both the same. I'm going to put the negative sign up at the top. So negative 1 over positive 2. So my rise is negative 1, so I go down 1. And my run is positive 2, so I go forward 2. Another ordered pair. Down 1, forward 2, another ordered pair. Down 1, forward 2, another ordered pair. Down 1, forward 2, another ordered pair. To find my other points, if I had put my negative sign down with my 2 and made it a positive 1 over a negative 2, that's how we get our other points, the opposite maneuver thing we talked about earlier. So now if I started back at negative 3, 3, it's positive 1 over negative 2, so my rise is positive 1, I go up 1, and negative 2 backwards 2, plot a point, and it's still on my line. connect all my ordered pairs with a line, draw arrows through them, done. The last example, our starting point is at the ordered pair 3, 4, so I start there. My slope is 2. I like slopes to be fractions because rise over run, so I can change 2 into 2 over 1. So it's positive 2, positive 1. If I go up 2 and forward 1, I'm off my graph. I can't plot points over there. So I can only plot points by doing the opposite maneuver. So I can go down 2 and backwards 1. Negative 2 over negative 1 is the same as positive 2 over positive 1. So down 2, backwards 1, ordered pair. Down 2, backwards 1. Down 2, backwards 1. Down 2, backwards 1. So that wraps up our notes on slope of a line. Slope, rise over run. Rise over run. Slope is rise over run. Don't forget, please. So rise over run. Bye, guys. See you next time. So slope, you've probably heard slope before. Slope is blip, blip. So slope equals down over how far does a line change left and right. It's too easy. So I like to do my express our slope as a ratio, rise over run. On this case, in general, slopes that do forward 3, and I'd have another ordered pair there at 3, 2. Then I could having a